Hi everyone, this is the first module of GCHM 100 for pre-health sciences. I want to remind you that it is a good idea to go through these pre-recorded slides and the corresponding readings early enough in the week so that you have time to create a list of questions for me to address during our live tutorial seminars on Fridays. It's also a very good idea to print out these slides so that you can add your own notes and questions as you listen to the slides, and they'll be an invaluable resource for your studying throughout the semester. Now, going through these readings will also give you some foundation for tackling the recommended practice questions at the end of each chapter. And here's a reminder that the topics for modules and the corresponding textbook readings and practice questions are all listed week by week in the weekly schedule, which you can find in the Learning Materials folder on Blackboard. And that's also where you'll see the schedule for your labs, assignments, quizzes, and tests. It's going to be vital, especially in this online format, for you to come prepared for tutorials so that you can participate more readily and have your specific questions addressed. Otherwise, without having done the readings or tried the practice questions, the tutorials will be of little benefit to you since there's no foundation or a reference point to figure out what you understand well and what you need to spend more time focusing on. In other words, you can't fix a problem you are unaware of. Another reason to keep up to date on things on a weekly basis is that I would like to reserve each week's tutorial seminar on Friday to that particular week's material. And only after we have addressed the week's intended material will I, time permitting, address questions that remain from previous weeks. And if we don't have enough time for that, then your questions might have to wait until closer to quizzes and tests, by which point it can be difficult to course correct. Now, also key to your success in this course is practice. Many of the concepts in the course can be abstract and or mathematical, and the textbook will be instrumental in that preparation. The details for the textbook are also found in Learning Materials, and I'd like you to please purchase this as soon as possible from the Humber Bookstore website. The link is in Learning Materials, and since it may take some time for the textbook to be delivered, there is also a link in Learning Materials for a limited time access to an online version. However, please note that this access will not span the whole duration of the semester, and you will need this textbook not just for this chemistry course, but for the chemistry course that you will take in the second semester. Having said all that, let's get started with the course itself. Our first module, Module 1A, is on matter, properties, and changes. All right. Every module starts with a list of corresponding sections in the textbook, and you can cross-reference material in these slides to those readings. You will also note that most of the images are from these sections of the textbook. And you'll see that there are key terms to understand and key outcomes. It's really important to know that the goal here is not necessarily to be able to regurgitate definitions. While the definitions are important, the real goal is to apply the terms and definitions to be able to achieve the key outcomes. And this course is very much process-oriented, but we do need a language to perform those processes. And here in this module, we are covering material from sections 1.1 and 1.2. Together, the key terms are matter, mass, volume, physical and chemical properties, and changes. And we want to be able to explain the differences between physical and chemical properties, between physical and chemical changes, and we also want to identify properties and changes as being either physical or chemical. I understand that many of you are planning to enter professions in the health sciences where you might think that subjects like biology and anatomy and physiology are going to be pressing on a daily basis. However, you have to keep in mind that underlying those subjects and many others is chemistry. Chemistry is at the root of a lot of those other subjects. And that means a strong understanding of basic chemistry can help you to better understand those other subjects. Those other subjects are about matter, and matter is really at the root of the study of chemistry. Now, matter is anything that has mass and volume. Mass is simply the amount of matter or the amount of stuff that a substance is made of. And it's related to, but not quite the same thing as, weight. The two often get confused for one another, and they get used interchangeably when in fact they are distinct from one another. It's true that the more matter there is, the more mass there is, the more a substance weighs. And that's because if there's more mass, then there's more for gravity to act on and pull down, and that's what produces weight. That means that the same amount of matter can have different weights depending on how strongly gravity acts on it. And lastly, volume is the amount of space that an object takes up, space being a three-dimensional space. Now, matter can be described by its properties or its characteristics. A list of properties can be used to identify what the object is because a given object has a unique set of both what are called physical and chemical properties. And these are the two types of properties that we're going to be discussing in this slide here. Physical properties are properties that can be observed or measured without the composition of the substance being changed. For example, an object's color, texture, luster, sheen, or shininess, its transparency, its mass, volume, density, and its melting and boiling points are just some examples of physical properties, because these can all be observed while the object's composition remains the same. In other words, the stuff that the object is made of doesn't change its chemical identity. If we look at, for example, the boiling point, well, we know that the boiling point of water is 100 degrees Celsius. And while we're making that observation that water boils at that temperature, well, during that time, the molecules of water, H2O, remain the same because we have two atoms of hydrogen bonded to one atom of oxygen, H2O, in its liquid form. And during the transition or the change of state to a gas, well, the gas molecules of H2O are still just two atoms of hydrogen bonded to one atom of oxygen. And that means when we're observing the boiling point of water, its composition doesn't change, and that's what makes boiling point a physical property. Similarly, when you observe the color of an object or its texture, well, as you're making that observation, the composition of whatever object you're looking at doesn't change either. By comparison, chemical properties are properties that are observed or measured when the composition of the substance is changed. Right? These properties can only be observed when the composition changes, and some examples include flammability, toxicity, acidity, heat of combustion, corrosiveness, etc. And these examples all relate to the substance's reactivity. In other words, the substance's ability to react or not react with other substances. And the key here is that when substances react with each other, they change their composition, either by the addition, removal, or rearrangement of atoms. Now, if we look at an example, or to explain this further, we can only notice that something has the property of being flammable when it's actually bursting into flames, right? Without that observation, we don't know that the chemical property exists. So when that happens, the molecules of the object are changed into something else. Whatever burned, whatever became flammable, reacted with oxygen to produce something new. We know that, as another example, we know that an object or a substance is toxic only when some unfortunate organism is exposed to it. And that exposure changes the chemical composition of the object as well. Hence, toxicity is also a chemical property. One way to think about physical and chemical properties is by establishing an analogy to a dating profile. So properties like height, weight, hair color, build, eye color. Well, those are physical properties because they can be observed while the person is still the same person, right? By contrast, we are probably all familiar with the notion that we aren't necessarily ourselves when we are with other people. And that's because we are, quote unquote, reacting to and reacting with other people. Whether we are reactive or attracted to someone else is all about our reactivity and our ability to react with that person. And when we don't or can't react with someone, we hear the common saying, we just didn't have any chemistry together. And we can only determine a person's likes and dislikes by seeing what that person reacts to and doesn't react to. Here's where we start to talk about physical versus chemical changes. Now, granted, it can be confusing to distinguish properties, which we just discussed, from changes, the topic of this slide here. The distinction between physical and chemical is the same as it was for properties. All right? The distinguishing feature there was whether the composition of the object changes or not. If it doesn't change, it's physical. If it does change, it's chemical. Now, the physical and chemical changes, however, are different than physical and chemical properties. Physical changes are changes in the substance that do not change the identity of the molecules. In other words, the atoms in the molecules are the same as they were before the change, in the same quantity and bonded to each other in exactly the same way. Earlier, I said that an object's boiling point is a physical property, right? It's a characteristic of an object to boil at a certain temperature. However, the actual boiling process of the object is a physical change. It sounds confusing, but let's revisit this. All right, the only way to observe a physical property is to observe a physical change. Right? It's by observing a physical change that we are aware of an object's physical properties. For example, we only know that the boiling point, a physical property of water, is 100 degrees Celsius because we observed water undergo a physical change from water to steam. Nevertheless, in both definitions, the definition of a physical property and the definition of a physical change, the molecules of water, being comprised of 2 hydrogen atoms and 1 oxygen atom, remain molecules of H2O. They still have 2 hydrogen atoms, each bonded to a single oxygen atom. The distinction between change and property is change is an actual process, property is a characteristic. Similarly, I said earlier that combustibility or flammability is a chemical property, right? An object has the ability to burn or burst into flames. However, the actual burning, the actual combustion is a chemical change because it's a process. And very similarly to the relationship between physical properties and physical changes, we can only observe chemical properties by observing chemical changes. Case in point, we know that octane, which is the main molecule in gasoline, has the chemical property of being combustible, right? It has the ability to burn. That is a characteristic that it has. And we know that it has the ability to burn. We know that it's combustible because we can observe it undergoing the chemical change. We can observe it actually bursting into flames. When octane combusts, it's no longer octane. Okay, octane, just FYI, is comprised of 8 carbon atoms and 18 hydrogen atoms. And after it undergoes combustion, we're left with a combination of carbon dioxide, CO2, water, H2O, carbon monoxide, the harmful byproduct of combustion, CO, and carbon due to unclean burning. So the composition of the original octane, C8H18, has become a combination of different substances. And it's chemical in nature because of that change in composition. The actual changing of composition is the chemical change, but the ability to undergo that change is the chemical property. To determine if the change we're observing is a physical change or a chemical change. Here we have on the left panel a strip of magnesium, and by appearances it looks metallic, it's lustrous, and we ignite this strip of magnesium. As a result, the combustion, seen here in the middle panel, produces a final product, which is this white ash of magnesium oxide. And to determine if it's a chemical change or a physical change, we're really asking, has the composition of the starting material been altered to this here? And the answer is yes, this is a chemical change because magnesium is not the same thing as magnesium oxide. The composition has changed. We observe this chemical change, or because we observe this chemical change, we know that magnesium has combustibility among its chemical properties. You'll also notice that when an object changes chemically from one thing to another, the physical properties that it started off with are no longer the same as the physical properties we end up with. Magnesium is this metallic, lustrous metal, whereas magnesium oxide is white and kind of brittle. In panel A here on the left, we have solid iodine, and when it's subjected to heat, it becomes gaseous iodine or iodine gas. The question being now, is that transition from solid iodine to gaseous iodine or iodine gas, during that process, are we witnessing a physical change or a chemical change? And again, the choice between the two depends upon whether or not the composition of the starting material is any different than what we end up with. Well, heat only makes molecules of iodine separate from each other and become more distant from each other to become a gas. However, the molecules of iodine are still the same. Solid iodine is comprised of the same stuff, the same atoms as gaseous iodine. So without that change in composition, what we are seeing here is a physical change. In the second panel, panel B, we have liquid benzene here. And when it's cooled in an ice bath, it becomes solid benzene. Okay, so liquid versus solid here. Now, cooling being the opposite of heating, well, rather than causing molecules to get further and further apart, cooling makes molecules come closer together, and that's how we have the formation of a solid. However, the molecules of benzene have not changed. Right? We have liquid benzene becoming solid benzene, but benzene is benzene. All the molecules are still benzene. That means that in both these situations here, we are witnessing a physical change. Now that concludes our first module. Here, like you will see at the end of every module, are these sections from the textbook with corresponding readings and practice questions. Now the practice questions are at the end of each chapter in your textbook. As I recommended at the start of the module, it will be so helpful to you to do these readings early in the week and to try to apply what you've learned in these slides and in the readings to complete as many of the practice questions as you can. Then, during the tutorial at the end of the week, you can ask very specific questions to clarify concepts that are difficult for you to understand. Make the tutorials, in other words, make the tutorials tailored to your individual needs as a learner. Please do not count on other students necessarily having the same questions and concerns that you do. So be prepared for those tutorials so that you can ask the questions to fill in the gaps in your own understanding. In tutorial, we can go over concepts in these slides, concepts in the textbook, or take up the recommended practice questions, time permitting. And on that note, I will see you at your first tutorial seminar session soon. Links to sign in to the tutorial are up on Blackboard in Blackboard Collaborate Ultra. Clicking on the link will give you access to the tutorial session. Take care.